Hello, welcome. Let's try to solve another Leetcode problem. 14, longest common prefix. So for this problem, we're gonna use a trie. So the idea of using trie is that we're gonna reduce the time complexity to 200 times 200. So basically, it is 10 to the power of 4. Yeah. So you can also use a other method like the easy way, n to the power of 3, that are gonna work. Yeah, because this is just an easy problem, but we're gonna use a better way to solve it. So that's gonna be a trie. Yeah. So how we gonna solve it? So for trie, basically it is a tree data structure, but it is totally different, and we have to define the trie data structure by ourselves, and then we're gonna just use it. So for example, if we just choose two words, flower and flow, so this is F. So from the trie, we're gonna prepare a trie node. So this is an empty node. It's gonna be pointed to F. It's gonna be pointed to after F. It's gonna have L. After L, it's gonna have O. So what about another word? It is FL. So this is F, this is L, and this is O. After O, it's gonna be W. And another one is flower. So this is the W, and this is the E, and this is the R. So by using trie, we don't need to check all the word. We just need to insert it into a trie, and we're gonna directly check what's gonna be the prefix. So after inserting for the trie node, if it only has one children, it means definitely it is a prefix, but it is not the longest. We have to check another one. So this is L, so it means FL is a prefix. Yeah, and then we're gonna continue. O, it is also okay. This W is the same, so we can keep it here. Instead of using 2W, we're gonna just use 1. So this W is just a single one. It is okay. Yeah. So currently we know that this flow is a prefix of flower and flow. But what is after that? After that, this is the E. Yeah. But at the right side it is empty. So we're gonna call it is a noun. Yeah. So as we know that, so the prefix is gonna be FLOW. It's gonna be flow because it only has one character. If we go forward, so for example, this is F, L, O, and W. So this is gonna be the final answer. So if we continue, this is FL. It's gonna be flight. This is I. So this means from this L, it has two children, O and I, so definitely it is not okay. So this means FL is the final answer. Yeah, I hope basically we understand about it. Yeah, but why this FLOW? Why here? How can we stop it from here? So let me just make it clear. So this is F, L, O, and W. But how can we stop it here? Because we should know if we choose two words, it's gonna be a flow instead of flower. How can we stop it from here? Because we need to define another variable for the trie. It's gonna be the end of the word. If this W is the end of the word, so definitely we're gonna stop it, and it's gonna be the flow, because this W is the end of the word. Another way is this is FL, but this is flight. This is I. So another way is if this node has two children, it means it has more than one children. So definitely we're gonna stop checking. So this means the final answer is going to be FL. So there are going to be two ways we need to check. Yeah. I think if everything is very is clear, so definitely we can write the data structure and try to solve it. So let's just first define the trie node. We're going to prepare two variables. One is the children, and another is the end of the word because we need it. Yeah. From beginning, I'm going to set it to false. Then we're going to use the trie node to define a trie. So for the trie, we're going to insert it. So we're going to define the root first. So the root is going to be the trie node. Then we're going to define another function. It's going to be insert because we need to insert this word into the trie. So for any character inside the word, so let's just prepare a temporary pointer. I'm going to call it current. So the current is going to be equal to the self.root. Yeah, because for each of the word, I'm going to use this current to insert it. So this is why I'm going to prepare a current. Otherwise, how can you insert it? Yeah. If say not inside current.children, if it is not inside, so we're going to create it. So we're going to build it. So we're going to build a trie node. If it is inside, so we're going to directly update the current. So finally, we're going to set the end of the word because currently we are sure the end of the word is going to be true. So this is the trie we defined, and now we just need to use it to solve the problem. So we're going to prepare current. We're going to prepare a trie first. So it's going to be equal to trie. And we're going to, for each word inside the strings, so we just need to insert it. So we're going to insert the word. Now we just need to prepare the final result. Yeah. So we're going to check the current. So this current is going to be, let's just define this current, going to be the trie.root. So this is the root. So from the root, we're going to continue to check. Yeah. So while current, if it is the end of the word, or we check the length of the current.children. If it's children, if it has more than one children, so we're going to break it. Otherwise, we're going to continue to check it. So what is going to be the character? We're going to use a list current.children dot case. We just need to check the case, but they're going to only have one case. Yeah. So list current.children dot case dot 0. It means we're going to check the next character. So this is the character we find. So this is a current, and current.children dot case dot 0. It means inside the trie, we're going to be the first character. It is this character, and we're going to update it. Yeah. And then we're going to update the current. It's going to be equal to current.children dot this character. So finally, we just need to return the result. Yeah, as you can see, this is not so difficult, but it reduces the time from. So if we use like a start with, it is n cubic, but it is reduced to n square. So basically, it is this 200 times this 200, m times n are going to be the final time complexity of the problem. Because as you can see here, we insert each of the word. This is all the word for loop. This is another insert, and for the insert, it is another for loop. Yeah. Now let me just run it to check if it works. As you can see, it works, and now let me just submit it. Yeah, as you can see, it's pretty fast, and this is a really good solution, I think. And this is gonna be about it. Thanks for watching. See you next time.